My name is Piyush and today I am going to demonstrate my Fuse security and notification system using ESP32 microcontroller. The main goal of my system is to monitor when food items are taken from a fridge, ensuring the authorized access and alert the user regards the item. The system uses ultrasonic sensors to detect the place and distance of the food item and guide the microcontroller what action to perform. I have also installed a OLED display to use to guide the user before the time exceed of the UID-based verification mechanism to approve the access so that unknown user can't access the food. This is a security measure which I have taken. In simple words, I combine electronics and programming to create a simple but effective smart food monitoring solution. So let's first understand the code which I have used to create this system. Firstly, I have included the y.h. It is the I2C communication library for OLED, and these Adafruit libraries are also for OLED display to initialize or display the control or the characters on the OLED display. And then I have used the new ping. It is new ping.h library to control the ultrasonic sensor. Here I have defined the dimensions of the OLED display which will be displayed, and this is the object which I have initialized to communicate with OLED display. Then I have I have defined the trigger pins, trigger pin 5 and echo pin 18. It will send a signal and it will receive the signal to calculate the distance between the object and the person. And here I have assigned the max distance, mean it will send a distance up to a maximum range of 200 centimeters. And then I have created a new ping sonar object. The new ping object handles the distance measured when the signal is sent and received automatically. Here then I have defined the buzzer pin to 23, and this is the initialization of the logic which I have used further in the code. Here I have set the time duration to 15 seconds and initial time or start time to 0 seconds. And then I have created a variable to store the input given by the user. It will be stored as user ID inside the user ID, and I have initialized the correct ID to 1234. Here we can also use a mechanism of NFC to check the or generate the ID, but it is not possible in software, so we are using or defining the ID in the system, in the code, so that it can be useful, so that I can demonstrate my project. And then I have created a function of reset system. It will reset all the settings of the system and start the system from the starting. And then I have created a void setup. It will initialize the serial beginning, means the serial monitoring it is initialize the bands of the serial monitoring system, and then I have set the pin mode. It will set the pin mode of buzzer to output, means the buzzer will give the output here. And next step I have initialized the digital write buzzer pin to low, means the buzzer pin will get low voltage or it will not work. Here wire.begin is used to initialize the I2C communication between the OLED, and if display not begin, means if the display does not show any, if the display does not show any command, it will show an error of the OLED display. If the display shows the settings, then it will print that the food security system, the name of our system, and the configuration which I have assigned in the further settings. Then I have initialized then I have created a void setup. It is the main setup of the program. Here we have set the sonar ping centimeter, means it will take the reading given by the ultrasonic sensor, and if the distance is 0, it will say 0. If the distance is 999, means no, not invalid input, it will say the distance 0 centimeter, and if there is some distance, we display the distance on the serial monitor. Serial monitor, it will display distance on, yeah, it will display the system of system, serial monitor. It will here I have created 4 cases for the proper functioning of the code. In case 1, if the distance is less than 50, the will start. Timer will start and it will ask the user to enter the UID. Here it will ask or display or print these commands in the OLED display, but you have to enter the UID in the serial monitor. It will pick the UID from the serial monitor and check whether it is correct or not. In case 2, I have set the timer but the distance, means timer is running but the distance goes back greater than 50, means if a person tries to touch the object but he withdraws his hand backward, then the system will reset automatically using the system function uh, created which I have created here by calling the reset system function here. Then in case 3, UID enter check, it will check the whether the person entered the correct UID or not. If he has entered the correct UID, then it will say the UID has been approved and the buzzer will not alarm ring. And if and it will reset the system again to the initial settings. And if he enter the wrong ID, then it will say try UID and display the same settings. In case 4, I have set the timer countdown display, means it will also notify the user that he has that much seconds to enter the UID. If timer running and not received, means the this is the simple logic I have used. If the to calculate the elapsed, it will subtract the initial start time from the millisecond at the present to calculate the value, and to calculate or display the remaining time on the screen. These are the previous settings which it will display on the screen. Then if the remaining time is greater than 0 or the initial time, it will display the time remaining on the screen and the buzzer will be low. It means it will not ring. And if it becomes greater, then The buzzer will alert the system and it will show the buzzer, it will give the buzzer the high voltage and the buzzer will notify the person using the alarm. And this is the setup which I have made in Walkme. Here, this is the ultrasonic sensor. It is the buzzer and it is the OLED screen. You can see that it is giving the distance, and on the OLED screen it is saying system ready. And if I decrease the distance, then to less than 50, it says timer start. The timer has been started. And the UID which have been initialized the code is 123, which says access received and the food item has been restored without alarm. And if I increase the distance, it will reset the system and say the system has been ready. And if I don't enter the any UID and or wrong UID, it will say the alarm has been ringing. Yeah, the alarm has been ringing. We cannot hear the sound of the buzzer, but we can say that the buzzer is ringing.
A boy opens the fridge and we see a food container inside with a small ultrasonic sensor on the container and an ESP32 board beside it, illuminated by a soft glow. The boy picks up the food item and the ultrasonic waves radiate from the container while a 15-second countdown starts on screen. The boy uses his smartphone to scan the NFC sticker on the food container, and the phone shows a green tick and access verified as calmness returns. An unauthorized attempt occurs as another boy opens the fridge without scanning, starting another 15-second countdown and building tension. When the timer ends, the ESP32 activates an alarm, ringing buzzer and red flashing. The fridge glows red, and a notification is sent to the owner and the thief, who both receive alerts. If the boy returns the item within 15 seconds and closes the door, the system returns to standby with calm blue lights and no alerts. Thank you for watching this quick overview of the food security and notification system.